Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, first, I introduce myself first. My name is Muhammad Shinawi bin Azudin. My big topic is climate change. So, is our topic, green transportation recommender suggest eco-friendly transportation method like bike, bus, and carpool based on distance, time, cost, and carbon impact. So, this one is a problem statement. So, many nations still use the high emission transport like private cars. They don't have access to eco-friendly travel suggestion. Need for a system that consider time, budget, and carbon concerns. Known to currently show the CO2 impact of each option. A smart system is need to guide user toward the greener transport based on the real-time data. So this one, our objective. Our objective is build an eco-transport advisor for Malaysia. Second is suggest transport option based on the user input, like cost, time, and carbon concern. And then we calculate the real CO2 emissions using the local data. And lastly, help user choose the greener, faster, and budget-friendly the travel option. So that's all for me. I will pass to my friends, Muhammad Shukri Supian.
So my name is Muhammad Syukri Sukan. So I will explain the system design of architecture. So the system we use the rule-based system, and the input is a distance, time, cost concern, and carbon concern. So the output is a best transport method that will be present. So this based on the graph, this is the user input. Then this is the input validation. Then the recommendation engine. In the recommendation, it will use the Malaysia data based on speed, emission, cost for each mode. So next, we'll go to the emission calculator, output filter, and next we'll choose the recommended output. Next is the knowledge-based reasoning. In this part is the content and transport data about speed, emission, and cost. So this is the data that we'll use for each transport method. Will what the speed, what the emission, and what the cost it will use. So for the example, is walk. The speed is in 5 km per hour. The emission is 0, and the cost is free. Bicycle is 50 km per hour, emission is 0, and cost is low. For the bus is 30 km per hour, the emission is 19, and the cost is low. For the car is 40 km per hour, the emission is 220, and the cost is high. So for the knowledge and reasoning, we have the if then rules. So for the if rule, we have a 7. So first is if distance is below 2 km and time is sufficient. So the system will recommend the walk. Next is 2 km, between 2 km and 10 km, and the carbon concern is true. Then time is sufficient. Then recommendation is a bicycle. Next is if distance is below 50 km and cost priority is low and time is sufficient. Then recommendation is the bus. The fourth rule is if distance is greater than 10 km and the cost priority is high and time is sufficient, then the system will recommend the car. Next is if carbon concern is true, then only allow mode with below 50 grams CO per meter. Next is if time available below the time required for mode, then exclude that mode. So if no mode qualified, so the system will default to the output is a car. So this is a forward chaining system. So you can see this is a forward chaining based on the inference rule. Next is the implementation. So for the system, we use the Python 3, and the design is a modular function and command line interface. So for the method is forward chaining rule-based system, just as before. So this is the example implementation that we use. Recommend transport. So this code is to filter distance, time, cost, and carbon content concern to show which transport method is suitable for the data. So that's all from me. I will pass it to the next person. Thank you.
Assalamualaikum and hi, my name is Nur Ayuni Akila binti Halim with ID number B0324103441. I'm going to present about my part, which is testing methodologies and result regarding our project system, that is green transportation recommended. We begin with unit testing. What is the function of unit testing? Unit testing will check individual component for accuracy. Okay, it validates the emission, input, and also recommendation for our project systems. So as we can see in the slide, there are 6 unit testing that are already being executed. So unit testing 1 Why we do it? Because it verifies emission calculation accuracy for carpooling 100 km. Also for unit testing 2 and 3, it checks the transport recommendations based on cost and carbon concepts. And the output match expected result, which means it confirming functions behave as intended. For unit testing 4 and 5, test input validation by providing edge cases scenario like too short distance, or we put the input like too short time, okay, to know if the error raised in the code is function or not. For unit testing 6, it validates user input against a list of valid option and provide clear feedback or invalid entries. So the conclusion for our unit testing of our project system is it confirms system reliability and readiness because it demonstrates throughout the test coverage across our core application. Okay, we continue with functional testing. What is functional testing? Functional testing will ensure the function operates as intended. Also, it could check the real scenario. System will raise an error about the distance, which is the distance must be more than 100 meters. The error will be raised with a note impossible time frame. It also recommends that if we put the distance 5 km, it requires more or an equal time of 3 minutes. We're going to test about the cost priority. So we show invalid input, and it says please choose from low, medium, or high, which is the option based on the option given. So we enter the right one, and yeah, the system will give you the output, the recommendation of our transportation, if we put in the correct choice based on the choices given. So that's all for the functional testing, and it confirms that the system reliably handles the valid and invalid input.
Hi, my name is Marwa, and I'm going to talk about critical evaluation. We tested our system to make sure it works properly, is easy to use, and gives fast results. For non-functional testing, we checked that the code is readable, easy to maintain, and safe from harmful inputs. It also responds quickly and handles errors well. For performance testing, the system runs smoothly even with big inputs. It doesn't crash or delays even during busy times. For usability testing, users will be able to use it without any help. The system also gave clear messages when there's an error and explained the recommendations clearly. Our system runs using Python frequent file and works through the terminal. To use it, just open the terminal, go to the folder with the file, and run python green transport.py. Then you enter 4 things like the distance, time, cost, priority, and whether carbon concern is important. After that, the system will show the best transport option and the carbon emission. For the limitation, right now our system has a few limits. It doesn't use real-time data like traffic and weather. It can't save user preferences, and it only has for transportations such as walk, bike, bus, and car. In the future, we plan to add live data using APIs, make suggestions more personal based on the user's past choices or budget, and also gamify the system by giving eco points or badges when the user pick green transport. That's all from our group. Thank you.